Hello students, welcome back again. This is Pallu Harish, faculty of CSIT. Okay, today I am going to start the fourth unit of digital image processing. This particular fourth unit, it deals with the change detection concepts. Okay, in case of change detection, pre-classification, post-classification change detection techniques, NDVI analysis, and different algorithms of change detections. What is the accuracy of the output of change detection that we get? How do we compute the accuracy? These are the different concepts that we are going to deal in the fourth unit of digital image processing. Okay, first we start with what is change detection. Okay, on the screen you are able to see two images of same study area. Okay, this is a imagery of different year, and both the imagery belongs to same study area of different year. It might be 1990, it might be 2000. There is a gap of 2000. Okay, basically change occur with the progress of the time. If the time is getting passed, obviously the change may occur. Using our remote sensing, using our image processing, we need to identify the change, how much amount of change has been occurred in a study area from so and so year to so and so year. This is about change detection. Okay, how can we find the change detection? Means change may be detected through comparison of a same imagery. Change detection can be observed, or it can be detected by performing the change detection for same study area of different years. Okay, there are different methods are there, different algorithms are there for doing the change detection. In the next sessions we are going to study those methods, these concepts. Basically change occur with the progress of time. That change can be detected using our image processing concepts. Okay, if you see on the screen, both the imagery belongs to same study area, but there is a change. It is occurred due to the passage of the time. Now, in order to find what the change has been occurred, we can use our image processing techniques. Okay, now we start the session with what is change detection. Okay, this particular change detection refers to process of identifying differences in an object or phenomenon by observing it at different times. The meaning is here we can identify the change detection for an object or phenomenon, but whatever the imagery you are taking, it need to be of different years. Okay, it is the detection of class transition between pair of registered images. The main goal of the change detection is to use remote sensing data to detect change on the landscape. Okay, means how much amount of change has been occurred in so and so study area. This is the main aim of the change detection. Next, change detection algorithms analyze multiple images of same scene, it taken at different times to identify the region of change. This is the thing that I have been stressing from the starting of the session. Change detection algorithm takes multiple images multiple images of multi-temporal data of the same scene to identify the change. Okay, changes on the earth surface could be directly caused by there are many reasons are there to identify the changes. The changes can occur due to the natural forces or by the activities of animals and human induced. Okay, these are the reasons. Means we should know the reason why the change is occurring. Means it might be due to human activity. If there is a farming land, if the owner of the particular farmland, if he is willing to construct any building, he can do. There the land is getting converted from farm vegetation to built up. Okay, it is getting changed from one feature to another feature. There are multiple reasons are there for occurring the change. It might be due to human, due to animal, or due to natural causes. Okay, if you take the example of in the Vizag, a hudhud has been occurred before and after hudhud. If you make a change detection, you can predict what amount of the loss has been occurred in that particular study area, how much amount of vegetation has been affected, how much amount of built up has been affected. Like that we can analyze multiple criteria using the change detection. Okay, next, Next, it can be performed with the remote sensing bands or thematic land core maps classified from them. Okay, the input for the change detection, it can be the satellite data, satellite band data, or multispectral data. Okay, good change detection research should provide the following. What is the thing means? How much amount of area has been changed? What is the rate of change? What is the spatial distribution of change types? And what is the accuracy assessment of change detection results? These are the 4 methods needed for good change detection research. Okay. Next, if you are doing any change detection for any study area, some pre-processing requirement is there. First one, start with geometric correction. Geometric correction means it mainly, if you are willing to do change detection for a study area of 90 and 2000, both the satellite imagery need to have same geometric correction. That means their projection and datum need to be same. If one is having WGS 1984 projection and datum, another need to also have same datum. Okay, if the projection and datum get changes, we can't perform the change detection. Okay. Next, radiometric correction, same thing. Both of them need to have the same radiometric calibrated data. If one is 8-bit data, if one band is 8-bit data, next other band also should be 8-bit data. If one band is 16-bit data, another band also should be 16-bit data. You should not take one band with 8-bit and another band with 16-bit. Both of them need to have same bit data. Next, if you are doing change detection, both the satellite imagery need to belongs to same area of interest. Next, okay, while doing the change detection, if in case of remote sensing, we need to take criteria of 4 things: spatial, spectral, radiometric, and temporal. Hope that you all are clear with these resolutions, no need to repeat again. Next, whatever the satellite imagery you are taking, that particular satellite imagery need to be free of clouds. Next, select time periods. If you are doing the change detection for 2 to 3 years in a village, you won't find any change. Why? Because it is a village. If you do the same thing for the any metropolitan city, you can identify a lot of change. Means based on this location of the study area also, you need to detect the time period. You can find more change if the time gap is more. Okay. Next, one more thing is land cover scheme classification. Which classification algorithm you are performing? There are multiple classification techniques are there to do the change detection. In later slides you will come across them. Next, choose change detection method and change detection accuracy assessment. What is the accuracy of your work that you had got? Okay. Next, this is the steps. I will be sharing this PPT to you. Just have a look for it. What are the steps involved in change detection? Means first, nature of change detection problem. What is the reason for doing the change detection? Next, selection of remote sensing data. Which remote sensing data you are preferring, either high spatial or low spatial. Next, image pre-processing. In image pre-processing, you come across things like geometric correction, radiometric correction. Next, image processing or classification. Here it comes across using which concepts you are going to process the classification. Next, selection of change detection algorithms. Which algorithm you are going to choose. Next, evaluation of change detection result. Now here in the last step, you are going to evaluate the result that you had got. Okay. Next, change detection techniques, change detection methods. There are different methods are there to doing the change detection: visual analysis, image differencing, image ratioing, post classification comparison, and statistical analysis. These are the 5 different methods. A part of our curriculum, we focus on image differencing and image ratioing. Image differencing is directly mentioned. Image ratioing, it comes under the post classification techniques. Okay, first we deal with visual analysis. For a glance idea, visual analysis. Visual analysis is the first place to start. Means this particular visual analysis, it won't require any algorithm or any visually. He need to identify on himself. Okay, it is the first place to start. Visually comparing multi images, more manual work is needed. Manual digitizing changes in multi images is often used to both identify and classify change between images. Next, elements of image interpretation. These are the techniques that are needed in visual analysis. Here in case of visual analysis, human presence is needed. He need to digitize the feature and in both satellite imagery. By performing the difference analysis, he can identify how much amount of change has been occurred. Okay, next, if suppose if you take this particular PPT, here wherever the cursor I am focusing, it is a water feature. In 1974 it is a clear water feature. The water level is more in 1974 imagery, whereas 2016 it has been, the water feature has been degraded due to certain issues. This is the change. Now in order to find how much amount of water feature has been changed or degraded, now user he need to digitize this feature and this feature. By doing the image differencing, he can identify what amount of land has been degraded. Okay, next, here I have said that by visual analysis, if you want to do the change detection, first you need to digitize the particular feature, then you can find the change. Next method is image differencing. In image differencing, same concept. If you are doing change detection for any study area, you need to have two satellite imagery of different years. In case of image differencing, you can do the change detection using the band data. Okay, let us assume that you all are clear with the Landsat 8 OLI. If you are willing to do the change detection using image differencing, first you need to take the satellite imagery of different years. Assume that I am taking for 90 and 2000. In 90, if you are doing the change detection for fifth band, by fifth band, in 90 select the fifth band, in 2000 satellite data select the fifth band. Okay, whatever the satellite data, whatever the band you select in the first imagery, you need to select the same band in the second imagery. You should not change the band. Okay, if you do this thing, only we get the output. Okay, next, the difference image is created by subtracting the brightness values of one image from the another on the basis of pixel based. Unchanged areas will have the value near to 0, while the areas with significant change will be either positive or negative. Okay, hope that you all are clear. If any feature is not changed, the value will be 0. If any feature is either decreased or increased, it will be either negative or positive. It reflectance value. Okay, just I'm showing a example in next slide. Assume that these are the two different satellite imagery reflectance value. If I do the chain reduction, my output will be this one, 1 minus 1. It will be done on the basis of the index basis. Okay, index 1 1 minus 1, the value is 0. Next, 3 minus 3, 0. If you focus on this value here, in imagery the value reflectance value is 9. In imagery 2, the reflectance value is 3. If you do image differencing, 9 minus 3, you get the value as 6. Here the differencing has been done y minus x. If you do x minus y, it will be positive 6. Okay, there is no issue here. If you focus again, 5 8 minus 5, 3. Okay, this is how the image differencing will be done. Image differencing will be done on the basis of the subtraction of the reflectance value in bands of satellite imagery. Okay, that is the reason I have said that if you are choosing the fifth band, you need to choose the fifth band for second satellite imagery also. Okay, you should not change the band. If you change the band, your output will be obviously erroneous. Okay, next, what is the advantages of this particular image differencing? It is easy to understand and implement. This method of analysis involves only subtraction with minimal human intervention. Next, the results of change detection are not subject to inaccurate inheritance in classified land cover maps. Okay, next, so long as the two images have been sampled to same ground resolution and projected to same coordinate system, the subtraction can be carried out quickly. Okay, next, limitation. This method is limitation, that it fails to reveal the nature of reflected image. Means this particular concept won't say what is the reason for occurring the change, just it does only subtraction. Next, identify threshold values of change and no change in resulting image. Okay, next, image ratioing. There is just 1 minute. Till now we have completed part of our curriculum. A part of our curriculum we have covered change detection, scope and methods, what are the different methods for doing the change detection, and spectral differencing, that is nothing but band differencing or image differencing. Okay, next we are focusing on post classification change detection. For post classification change detection, we discuss the particular concept using the image ratio. Okay, Next, image ratioing. Similar to image differencing only, this concept also works. There you are doing the division, subtraction. Here you are doing the division. Okay. Values near to 1 indicates no change in image ratioing. Values greater or less than 1 indicates changes. Okay. Next, here if you take the example, same thing. There you have perform. Here also the image ratioing occurs index wise. 1 divided by 1 1, 3 divided by 3 1, 3 divided by 3 1, 5 divided by 5 1. Okay, like that it goes on. Next, 7 divided by 5. Here the value is 0.7. Okay. There the difference change has been change is getting occurred by differencing. Here the change is getting occurred by ratioing. Okay. Next, most popular method of this is the most popular method of change reduction in post classification comparison. Each data of rectified imagery is independently classified to fit common land type. Next, land cover maps are overlaid and compared pixel by pixel basis. The result is map of land type change. Next, the change map display acreage of each change class. Okay, this particular image ratioing belongs to post classification technique. Advantages: many classification algorithms can be directly used, easy to quantify the area of change and rate of change. It also gives the attribute changes. Okay. Limitations: is this particular method is also having limitations. Classification accuracy directly influence the accuracy of change detection. It is time consuming to create the classification results. It is difficult and expensive to obtain appropriate multi-temporal ground reference. Okay. Next, sources of error in change detection. What are the sources of error? Error in data, image quality. First, if the quality of the image is good, you get the good accuracy data. Atmospheric error, you need to choose the images which is free from the atmospheric error. Next, misregistration should not be existed. Both of them need to have same geometric correction and radiometric correction. Next, seasonal variability. Okay, it is also if one for the imagery one, if you are taking Rabi data, and imagery 2 if you are taking Kharif data, it is not, you will get the result but your accuracy will be degraded. Try to choose same seasonal data. Next, processing error. Next, radiometric error. Okay, these are the sources of error. If you take care of this thing, you get a good accuracy data. Next, application areas. Where can you apply means land use land cover change. If you want to compute land use land cover change, we can do the change reduction. Similarly, urban growth, for urban sprawl also you can do it. Next, if in case of deforestation, disaster monitoring, for agriculture change, coastal change, you can use this particular chain reduction. Okay, I will show a sample example which has been done to a study area. This particular 1996, it is a land use map of land cover map of a particular study area. Okay, you can using the legendary, you can find brown indicates barren salt, similarly blue indicates dam. Okay, this is 1996 data of that particular study area. Next, this is the 2008 data of satellite same study area. If you do the change reduction either using the band difference, what are the output I'm showing, it has been got using the image differencing. Okay, for 1996 to 2008, what is the change has been occurred? This is the change. Farmland has been changed in farmland was in 30.267, whereas in 2000 it is 30.772. What is the change? What is the if you do the change, you can find the obviously the change is getting in decimal numbers. Here the change rock outcrop, it is 4.6, it is 4.0. okay, or else you by the percentage also you can change. It is 74.71, it is 75. You can find the change. It has been farmland has been increased from 96 to 2008. Similarly, rock outcrop has been decreased by 7%, by 2%. Similarly, bare soil has been increased by 1.5%. Similarly, forest reserve has been decreased by 0.3%. Like that you can do the change detection. Okay, next, this is the try to use this references for good material of change detection, or else you can find the same thing in Gauss book or one more Richard's book I have shared to you. Okay, thank you for listening. In the next video I will show how to do the change detection by image differencing. Same concept you can do by band ratioing also, but I will show you only a image differencing. Bye bye.